Good day everyone, we are from Group 26. We are going to present the topic Normal Distribution from Chapter 3. Let's dive in to understand the theory of normal distribution. Normal distribution is also known as Gauss distribution. It is a continuous probability distribution that is symmetric about its mean, showing that data near the mean are more frequent in occurrence than data far from the mean, and usually represented by a bell-shaped curve.
This is the formula of normal distribution. If x is a random variable whose probability density function is normal with mean, mu, and variance sigma square, it is written as shown. This is the probability density function of a normal random variable. So we can see that the normal curve is symmetric around the mu, so that the mu is the median as well as the mean.
So now let us have a look on the application of normal distribution. So in these problems, we know that a machine produces a kind of bolts which the measurements are normally distributed with mean of 4 mm and variance of 0.09 mm square. Bolts are measured accurately, and any which are smaller than 3.5 or bigger than 4.4 mm are rejected. So the question is how many bolts would be accepted out of a batch of 1000. So let's do some analysis. From the question, we know that the mean is equals to 4. The standard deviation, which is square root of variance, is equals to 0.3. The number of bolts in a batch is 1000. And we assume that the variable capital letter S has the measurement of bolts in millimeter, so the range for accepted bolts are between 3.5 to 4.4.
With the previous analysis, we can solve this problem. The first step is we convert to the standard normal distribution by using the formula which z equal to x minus mean divided by standard deviation. In this case, the z1 will get negative 1.67 and z2 will get 1.33. The following step is use the normal probability table to find out the probability that is in between 3.5 and 4.4. In this case, to find out the probability that is in the range, we need to use the probability of z2 minus the probability of z1. The value for the probability of z2 can be found by referring to the table, which the probability less than 1.33 in the table is 0.9082, while for the probability of z1, which is less than negative 1.67 in the table, is 0.0475, and the result of 0.8607 is shown as the probability that is in the range. The last step is you need to find out the number of bolts that is accepted in the 1000 odd batch. To find out the numbers, we simply multiply the probability with the 1000, and the number round off to the 861 is the final result that is accepted.
This is the conclusion of our assignment. From the application shown, normal distribution allows us to estimate the number of bolts with accepted measurement. By knowing the estimation of qualified bolts produced in a batch, manufacturers may control the price of bolts to maximize their profit. To sum up, normal distribution can also be applied to analyze other industrial products. That's all from us. Thank you.